Hi, boys and girls. Welcome back. We are doing the math portion of the IReady lessons for April 6th through the 9th. Okay, I'm going to be honest with you. I did 4 or 5 previous lessons on this. One on the mean, one on the mad, one on dot plots, one on all the other terms that we have to talk about. And it was just like too much. It was like, here's a video, there's a video, there's a video, there's a video. And so after consulting my teacher friends and after going on Khan Academy, I decided to just go ahead and put this all together in one video. It might be a little bit longer than our reading ones, but it's going to have all the information. Okay, the good part about this is that almost everything is review. Almost everything is review except for MAD. That's going to be our new one. But everything else that we're going to be talking about is review. So I'm going to touch on those first, and then we are going to do the MAD, which is, I'm just going to give you another spoiler. It's mean absolute deviation. That's what it stands for. It doesn't stand for, oh my gosh, Miss Elliott is so mad she has to stay home and can't see her kids. No, I mean, it's true, but that's not what it is. So we're going to start with the vocabulary. The first one, we have mean, mad, median, dot plots, and I threw in a couple extra. I threw in mode, outlier, range, because those are all ones that we need to review on. So let's look at the first one. This is going to be our big word this week, mean. And it's really cool because you guys know how to find the mean. You guys got like 4 out of 4s on your exit tickets with the mean. So I was super excited about this lesson. So we're doing the mean. We're going to go into this one later, but we're talking about the mean right now. The mean is the measure of the center. That's the measure of the center. That's the average of the value of the numbers in our data set. Now this one, the mean absolute deviation. Again, here's that word, mean, mean. Average, average. Absolute. Remember, absolute means it's neither positive or negative. This is the number of jumps from the mean to the other number in the value along the number line. Deviation, that just means difference. Like, what is the difference between the mean and where this number is, the absolute number of jumps? So we're talking right here. Can you guys see that okay? This is the average distance between each data value and the mean. Again, we're talking about mean. Super important to know what that is. On IReady, you're going to hear it called fair share and balancing point. And it's how spread apart the numbers are. When we do our dot plots and you get to see it, it's a lot easier to figure out what the mean, what the MAD is. The mean absolute deviation. We're going to come back. Don't forget that. Okay? Then we're going to talk about the median. Oh, I love this one. The median's pretty fun. That's the middle of the number. The mode, that's one that occurs the most often. The outliers, these are the numbers that are the farthest away from the mean. Oh, look, there's our word again. Mean, mean, mean. It's all over the place. The outliers are the ones that are the farthest away. And then we have our dot plots. That's a visual frequency table. It's also called a line plot. Do you remember in math when we did our tally charts and then we made a line plot? Yeah, it's the exact same thing. It's a dot plot. I like those. Those are fun, and it's fun to say. So, dot plot, right? Okay, so the first thing, I'm just going to review with you how to find each one of these, and then we're going to hit the MAD, the mean absolute deviation. So with the mean, remember that's the average. So you add up all the numbers and the values in the data set together in order to find the sum. The sum right there kind of gives you a clue. Oh, we're going to add them up together, right? And then you count the number of values in the group, and we have to divide by that. We have to divide the sum by the number of values. So here's my example. And yeah, I didn't get too creative on this. I did, and I made the numbers really hard, and I'm just like, no, there's no need for that. So we're just going to do this. Ready? So my numbers in my data set are 2, 3, 4, 5, and 6. The first thing I have to do up here is I have to add the data together, add the values together. 2 plus 3 plus 4 plus 5 plus 6. That equals 20. Then I have to count the number count the number of values in my group. I'm not going to count this as 2. I'm going to count this as 1, 2, 3, 4, 5. So I'm going to take the total number when added together, that's the sum, when I add it together, and divide it by the value, how many there are. 5. 20 divided by 5 is equal to 4. So one way that I could do this is I can make a dot plot, or I can actually just not make a dot plot yet, but I can do 20, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 20 dots. And I'm going to make groups of 5. So I have one group of 5, another group of 5, another group of 5, and another group of 5. So how many groups of 5 do I have there? Yeah, 4. So that's how I got my 20 divided by 5 is equal to 4. I can also use my multiplication chart to figure that one out. That's what you guys like to do. It's really good. All right, the next one we're going to do is the median. The median is one of my favorites because it's so fun. It's finding the number in the middle. The first thing you do is you have to order the numbers from least to greatest. That's the smallest number to the largest number. And then you cross off the pairs of numbers starting at one side and then the other side. You cross them off until you get one last pair of numbers in the middle. And if the numbers are the same, yay, that's your median. But if you have two different numbers, then you have to find the mean of those two numbers as well. So let's look at our examples. And I know I made them really simple. You're welcome. All right, so we have 12, 3, and 5. So I put it in order from least to greatest, 3, 5, 12. I counted off this pair, and I am left with 5. Woo! Yay! That's my median. Over here, I added 4. So my numbers are 12, 3, 4, and 5. So I put them in order again from least to greatest, 3, 4, 5, 12. I counted off these pairs, but look, I'm left with 2 in the middle, and they're different. So then I have to go all the way back, and I have to do my whole mean again. 4 plus 5 equals 9. 9 divided by 2 equals 4.5, 4.5. And that's going to be the median there. Review. This is fun, right? Okay, this is another one that I really like. This is the mode. This is the one that occurs the most often. So here is my set of data. I have 2, 2, 3, 3, 3, 4, 5, 6. So I made a dot plot because a dot plot is a visual representation of my data. Look how easy it is for me to find the one that occurs the most often. Yep, 3. Got it. Okay. The outlier. The outlier is the number that is farthest away from the mean. So the very first thing I have to do, here are my numbers. Shoop, I added 14 on that. Okay, do you see that? Here is my number. We already found out that the mean is going to be over here somewhere. So now I can see my outlier is 14. There's my outlier, 14. I added all these up together and I got 48. I'm trying to find the mean. Add them all up together, I got 48. Then I divided 48 by the number of values. There's 10. And the mean was 4.8. Well, that's quite a bit different, isn't it? This is pretty far away from 4.8. This is my outlier. Sometimes the outlier can really skew your data, so you want to make sure that you take that into consideration, that that's where your outlier is. Then we have the range. The range is the difference between the largest number in your data set and the smallest number. So if I had 10 was my largest number, 5 was my smallest, I'm going to subtract those. 10 minus 5, 5. That's my range. And then dot plots. Dot plots, that's our visual representation. Oh, does this look familiar? Absolutely. Okay, so here I use the number of minutes it takes to eat Whoops. Okay, I'm sorry about that. Siri want to do math with us. So this right here is the number of minutes it takes to eat lunch, and this is how many kids said that took them that long to eat. So then we just took this information and plotted it in a dot plot. Voila, we have a line plot or a dot plot. We're going to be doing that this week on IReady too. Okay, so now that brings us to this, the mean absolute deviation. All right, so the mean absolute deviation is the average of the distances that each data point is located from the mean. And I use two sets of examples here. So I'm going to do this first one. All right, my numbers on this first one were 2, 2, 4, and 4. So the first thing I had to do was find the mean. So I took the values 2 plus 2 plus 4 plus 4, and that got me 12. Then I had to divide that by the amount of numbers in this set. There's 4, right? So I took 12 divided by 4. So that means how many groups of 4 are there in 12? There's 3. That's my mean. So then I put it on a little dot plot. If I did this 1 through 5, I had 2 2s, 2 4s. Oh, look, there's the middle. That's my mean, 3. It's right there, okay? So now, this is where I have to find the mean absolute deviation. That means that I've got to find out how far apart each one of these dots are from the mean. So I'm going to find the absolute value. It might look like a negative number, but it's not, because remember, absolute values are not negative numbers. It's just the number of jumps from that number on the number line or on the dot plot to the mean. So the first one I'm going to look at is 2 and 3, because my mean is 3. So I'm looking at this 2, right? This 2. So how far away is it from 3 to 2? It's just one jump. Oops, I have another 2. I have to do it again. How far away is it from 2 to 3? One jump. Then I have to do 4 to 3. How far away? Here's my 4. Here's my 4. How far away is 4 to 3? One jump. And I have another 4. How far away is it from 4 to 3? One jump. So now I have the number of jumps, the number of the distance away this number is from the mean. So I have 1 plus 1 plus 1 plus 1. 1, 2, 3, 4. Yay, that equals 4. 4 divided by 4, 1. That's my mean absolute deviation. It's 1. So the average of numbers, the average of jumps, each of these numbers in my data set are from the mean is 1. That's how far each one of these is from the mean. That's just the average. Remember, mean is the average. So that's saying that the mean absolute deviation is 1. Let's look at this data set. So I have 1, 1, 6, and 4. All right, so I have 1 plus 1 plus 6 plus 4. That's equal to 12. And then I took 12, divided it by 4, and I got 3. Well, hey, look, that's the same mean as this set, isn't it? But if I look at my dot plot down here, it's quite a bit different. This dot plot looks a lot different than this dot plot. So this dot plot, again, I've got to find out, here's my mean, yay, it's 3, but I've got to find out how far away each one of these numbers in my data set is from my mean. So I'm going to start with the 1, okay? I'm going to count. What is the distance between my 1 and my 3? 1, 2, 2. Oh, I have another 1. Yay! I'm going to count the distance. 1, 2, 2. Now I have a 6. I've got to go over here to my 6 and find out how far away that is from my mean. I can go 1, 2, 3. I know that the distance, the deviation, is 3. I could have also just said 6 minus 3 is 3, but I want to show you guys that it's the distance apart from the data point to the mean. My last one is 4. So for the distance, 4 minus 3, I could have just said 4 minus 3 is 1. But if I look at this, I'm going to say 4 to 3 is 1 jump. That's the distance. So now I have the deviation, the distance away from the mean is 2 plus 2 plus 3 plus 1. That equals 8. But I have to divide that because I'm still looking for the mean. That's the M in MAD. I'm still looking for the mean. So I have to divide it by the numbers, the number of points in my data set. I have 1, 2, 3, 4. So I got to take this 8, divide it by 4, and that's going to give me 2. That's my mean absolute deviation. Well, look, we have the same mean on both of these data sets, but this mean absolute deviation was 1, and this mean absolute deviation was 2. They had the same mean, which was 3, but they had different MADs. And that's okay, because the smaller the mean absolute deviation, that just means that the data value is closer to the mean. The larger the mean absolute deviation, that means that most of the data values are far from the mean. So there's a lot of information in this. If you get stuck, please feel free to call me, to text me, to video chat with me, do whatever you need to do to get through this. It can be a lot of fun. I had to go on Khan Academy and get some ideas on how to present this because it just seemed like it was just too much information. And I think that's a really good idea. If you guys want to go on Khan Academy, that's a great idea. So if you get stuck, please call me. Please review this video. I know it's almost 20 minutes. But the other ones were like 3 minutes, 4 minutes, and I'm like, okay, I'm just gonna put it all together as one. And hopefully we can just get this, we can do it together, and you guys are gonna do great. Okay, as always, remember, Miss Petty, Miss Dickman, myself, Miss Johnson, Miss Sanders, Miss Murphy, Miss Shaker, Miss Landris, and Mr. Wald. We are all here for you. We are all in this together. So stay strong, stay safe, and stay healthy. And I'll see you next week on videos. Call me, video chat with me, message me if you need help, okay? I'll see you guys later. Bye.